Hello everyone. We are going to talk about the production of jet biofuel today. And why the jet biofuel? Basically, there are some kind of properties for jet biofuel that should be met for the industry or for basically the aviation fueling. Here, this is just example of the common ones: Jet A, Jet A1. This basically kerosene type of jet fuels, and Jet 1 is used in the US, and Jet 1A is used somewhere else in the world. And GP is basically this synthetic type of biofuel that is actually called jet propellant, and is again is the synthetic type of fuel that can also be used for military application. And this diesel one is the common diesel type of fuel. Again, the density also may be comparable here, but the most important actually is the freezing point. The freezing point for this fuel should be low enough to prevent the uh, solidification or to become solid under lower temperature, especially in the the atmosphere, basically in high in atmosphere. Uh, and also this flash point should be more than 38 degrees C. And the flash point is the lowest point that, or basically the temperature at which the temperature, the liquid will be ignited if it's contacted or exposed to flame or maybe some kind of high heat, basically like sparking. Again, this is the viscosity here also should be low enough to be easier for injection and so forth. And the specific gravity also may be comparable to diesel one. However, actually the density for the GP10 is a little bit higher. Okay. So the common actually hydrocarbons that can be used as jet fuel, actually this kind of natural medium chain length isoprenoids and the fatty acids derived from hydrocarbon to meet such requirement for the jet fuels. And isoprenoids are common and diverse class of naturally occurring organic compound, and they have been actually applied also in pharmaceutical or fragrance application besides the fuel industry. They can actually also be reduced in by condensation of two or more isoprene units. Naturally occurring in plants basically through some kind of some busways like MVA busway, and this basically the mevalonate busway, or maybe also methyl erythritol uh, phosphate. This is basically the second pathway for this production of this isoprenoids. Um, so, however, actually, because of they are naturally occurring in plants, they are actually low quantities. Basically, it will be affecting the cost, and of course, this yield, of course, will be a challenge basically for uh, industrial application. For this actual reason, maybe also uh, they may be produced chemically sensitized basically by condensation uh, of two units, as we mentioned here, basically condensation of two more isoprene units, and to basically to as alternative to production in the natural plants. However, actually, the complexity of stereochemistry of isoprenoids will be a limiting factor, especially for high cost and also undesired yields. In addition to that, the chemically sensitized um, isoprenoids also may produce hazardous solvents that can be having some kind of negative effect on environment. Therefore, microbial cells uh, can be, or basically microbes, can be used as factories for biosynthesis of isoprenoids, especially from low-cost renewable feedstock like biomass or maybe biowaste. However, still also maybe they have some kind of challenges, especially for effectiveness of the bioprocesses to produce high yield of this kind of isoprenoids. So maybe actually you're familiar with this one. Basically, this is a potential feedstock for biofuels. Maybe the first generation, this is basically the food and food type of crops that can be used for producing sugars or starch, can be used also for producing biofuels. This basically has some kind of high cost of material, and also the competition of food and energy. This also has a limiting factor there. This basically come to the second generation to use lignocellulosic materials, and also basically waste materials. However, the structure of this material also can have a cost limiting factor. And however, the material itself may be low cost, but actually processing it may be needing actually more like pre-treatment or enzymatic hydrolysis, for example. Come to the third generation. Basically, this is basically from algae and cyanobacteria, and can be cultivated in non-arable land, means that it can't be compete with food. However, actually, the high cost of cultivation may be a limiting factor there. Come to the next generation, which is the fourth generation, basically derived from engineered algae and cyanobacteria. It's similar to third generation, of course, but of course, the improved of by productivity. After we have this kind of biomass, this basically should have pretreatment again and some kind of fermentation to produce terpenes. Basically, this more actually uh, more actually steps here to show how this can be reduced. So basically, this pretreatment, we handled this before, either physical or chemical pretreatment, and then enzymatic hydrolysis to liberate basically the sugars, and then use the sugars actually in saccharification, and then have this kind of also fermentation into cells using also the mevalonate pathways, and also methyl erythritol as pathways to produce these units. And this kind of material can be updated or maybe purified to produce jet fuel. This is basically this kind of multiple unit operation after each others. However, actually, this kind of simultaneous saccharification or maybe saccharification and fermentation can happen also in this process. Basically, you consolidate different bioprocesses to produce this kind of terpene synthesized material. This is just example also for summary of progress in microbial production of advanced jet fuel candidates. And here, basically, this is a yield of each of this terpenes, and also the microbial host or microbial cells that can be used for this kind of terpene producing agent. Again, this is also the feedstock. Maybe glucose means that you can actually use um, um, biomass to produce glucose, and then use this as fermentation, and then update it to the terpenes. This I'm not actually going to go in details, but actually, again, this is basically this is the article that I used to prepare this, and you can go and read more about this. If you have any question, just let me know. Thank you. Bye.